Hello everyone, this is Jankit from Kailasha Foundation Fun and Learn portal. Today we are going to discuss our uh, Algebra Basic Lecture 2 of New Course 2019. In the previous lecture we were discussing polynomials, so we are going to continue from that point only. We will discuss types of polynomials. Polynomials are classified under many heads, and the first basis of classification is by coefficients. By coefficients, we classify polynomials uh, in three kinds. The first one is polynomials over the set of integers. Polynomials over the set of integers. 5x square plus 3x plus 6. And see, all these are integers, 5, 3 and 6. All these are integers. So this is polynomial over the set of integers. If we allow fractions also as coefficients, then polynomials over the set of rational numbers. Okay, if we allow fractions also, that means 2 by 3x square minus 4 by 5x plus 6 by 7, or say it is 6 only. Still, this is not an integer. This is not an integer, though this is an integer. But all these are rational numbers. All these are rational numbers. If one category is to be chosen for all these, then these are rational numbers. So this is polynomial over the set of rational numbers. And the third one is a bigger category. Uh, Polynomials over real numbers. All these will be automatically included in this third category also, because these all are real numbers also. These all are real numbers also, and in real number the restrictions are lifted. Now we can consider irrationals also. So root 3x square minus 4 by 5x plus 2, this is a polynomial over real numbers. This is also a polynomial over real numbers. Okay, so this is a bigger category. Thereafter this smaller than that, and this is the smallest polynomial over the set of integers. Okay, now the basis of classification is second is by the number of terms. By the number of terms, I just told you in the previous lecture what do we mean by terms in an expression. So number of terms, first one is monomial, that is a polynomial in which there is only one term. Okay, this is paradoxical because polynomial means something. Polynomial means expression containing more than one term, but now then there is this monomial to identify some polynomials and which are having single term. So consisting some a polynomial consisting a single term is called a monomial, that is root 5x or minus 8y square or 15k square, etc. Only one term, only one term, only one term. So these are monomials. Then we have binomial. Binomial means two terms. Trinomial, three terms. and thereafter we have polynomials for more terms. Okay, by degree, third basis of classification is by degree. So first of all, we have to understand what is the degree of a polynomial. Degree of a polynomial. The highest exponent of any monomial of the given polynomial is called the degree of the polynomial. For example, x power 6 minus 3x power 4 plus 12. The highest exponent of any monomial of the given polynomial, highest exponent is 6 here. Okay, highest exponent is 6, so degree of polynomial is 6. 5y cube is a monomial and its degree is 3. 4x square y cube z square, this is one term, this is a single term, and the degree of polynomial is not 3 but it is 7, because all these powers are added and total degree is 7. Degree of this polynomial is 7. Root 5 x cube y cube, it has a degree 6. Okay, y power 7 minus 5x square plus 3y square, it has a degree 7. So the highest power, the highest exponent of any monomial of the given polynomial is called its degree. Okay, so by degree of a polynomial we can classify polynomials into linear polynomial, quadratic polynomial, cubic polynomial, okay, etc. Linear polynomial is 2x plus 5 x power 1. Okay, the power of x is 1. 3y minus 2 root 3y plus 7 by 3. The power of variable is 1. Okay, these are linear polynomials. Also 2x plus 3y, here also the power is 1, here also the power is 1, in both monomials the power is 1, so the degree of this polynomial is 1, so it is a linear polynomial. All these are linear polynomials. Thereafter quadratic polynomial, 2x square plus 3x plus 2 or 5x square plus 3y or 2x square plus xy. The highest power is 2, highest power is 2. Here the power is 2 and here also the power is 1 plus 1, that is 2. So highest power is 2. If highest power is 2, then it is a quadratic polynomial. If highest power is 1, then the linear polynomial. And if highest power is 3, then it is a cubic polynomial. It is a cubic polynomial because the highest power is 3. So now we will see factorization of a polynomial. factorization of a polynomial. I'll show you a few examples. X square plus 2xy plus y square. If you directly remember the formula, then it is easy for you. Otherwise we can do it like that, like this. X square plus 2xy can be written xy plus xy plus y square. This is taking x common, x plus y, and then taking y common, it is x plus y. Now there are two terms. From both the terms, taking x plus y common, x plus y common, sorry, we get x from here and y from here. So x plus y. Okay. So the factored form of this is this x plus y times x plus y, or we can write it as x plus y whole square. Similarly, you can write x square minus 2xy plus y square as x minus y whole square. That means the terms are separate. Here there are three terms, and when you write in a factored form, it becomes one term. Okay, because it is in multiplication, there is no addition symbol or subtraction symbol there in between. So this is now one term, x plus y whole square. This is now one term, x minus y whole square. Okay, inside the bracket there are two terms, x minus y. Okay, x and minus y, but as a whole this is one term. Okay, so some basic algebraic identities are uh, two of those I just told you, and thereafter x square minus y square can be written as x plus y into x minus y, x cube plus 3xy plus 3xy square, sorry, 3x square y plus 3xy square plus y cube. This can be written as x plus y whole cube, x cube minus 3x square y plus 3xy square minus y cube can be written as x minus y whole cube, x cube plus y cube. This can be written as x plus y into x square minus xy plus y square. X cube minus y cube can be written as x minus y into x square plus xy plus y square. Okay, we can factorize polynomials like this: x square minus 5x plus 6. If we have to factorize this, we can split this in two parts: x square minus 2x minus 3x plus 6. The key is that the product of these two is equal to the product of these two. We have to be wise in doing this. Okay, taking x common, we get here x minus 2, and taking minus 3 common, we get x minus 2 again. Now taking x minus 2 common from both, we get x minus 3. So this is the factored form. Okay, now we move on to functions. Functions. So functions basically it is useful for all students of class 12th, class 11th also. It is for CA CA Foundation. It is for CAT also. Okay. So functions are basically algebraic expressions and also other expressions which have definite values as results. We'll show you what functions are. For example, x square minus 8x plus 15, it is a function. I am expressing it as fx. Okay. At first I am telling you what is fx, and let us take another function. Gx is equal to mod x, and let's take hx is equal to x plus 2 by 5. Okay. So now if we put f3, so we had x, so there x and x. Here there was x, so x and x. If we have replaced x with 3, then it will be 3 square minus 8 into 3 plus 15. Okay, that is 9 minus 24 plus 15. That is 24 minus 24. That is 0. If we have to find f1, then it will be 1 square minus 8 into 1. X will be replaced by 1. X is replaced by 1, so x will be replaced by 1 here also. 1 square minus 8 into 1 plus 15. So it is 15 plus 1 minus 8, that is 16 minus 8. So 8. Okay, if we have to find g minus 2.4, we'll simply put minus 2.4 here. It will be plus 2.4. Because mod works like that only. G 13.9, it will be mod 13.9. X will be simply replaced by whatever is written here. So mod of 13.9 is again 13.9. If we write h3, then it will be 3 plus 2 by 5, that is 5 by 5, that is 1. If we write h minus 2, then it will be minus 2 plus 2. X will be replaced by minus 2. 0 by 5, that is 0. So all these are functions. All these are functions. Okay. When we express an expression like this or this, then it becomes a function. For example, we had x square minus 5x plus 6. This was an algebraic expression. When we write this, it becomes a function. Okay, it becomes a function. So y is same as fx. Y is basically same as fx. Okay. Now we will take a look at graphs. We will also consider types of functions. So how do we make graphs from functions? How do we draw a graph of a particular given function? For example, let's say we have y is equal to x square. when there are two variables, when there are two variables, listen carefully, when there are two variables, the graph will be in one plane. Okay, it will be two dimensional. When there are two variables, the graph will be two dimensional. Basically it will be planar. X and y, there are two variables, so x and y axes are needed to be drawn. X, y. Now we try putting values on our own, whatever we feel like we should put here. In x, we try putting the values. For example, if we put 0, then it is 0 square, that is 0. If we put 1, then it is 1. If we put 1.5, then it becomes 1.5 square, that is 2.25. If we put 2, then we get 4. If we put 3, then we get 9. If we put minus 1, we get 1 again. Minus 1 square is 1. Minus 2, then 4. Minus 3, then 9, etc. Now we mark these points on the graph. Now we mark these points on the graph: minus 1, minus 2, minus 3, 0, 1, 2, 3. This is 1.5, 1, 2, 3, 4, and high above there will be somewhere 9. Okay, so 0 comma 0 is one of the points, 1 comma 1 is another, minus 1 comma 1 is also a point, 1.5 comma 2.25 is here. Okay, then we get 2 comma 4, then there is 3 comma 9, then we have minus 2 comma 4, minus 3 comma 9. Okay, so this when we join these points with a smooth freehand curve, when we join these points we get what is called the graph of function y is equal to x square. Y is equal to x square, this is the graph of that function. And we can notice a few points. It is passing from 0 comma 0. It is a smooth curve, not a sharp, it is not a sharp turn, but it is a smooth turn. Okay, uh, it is above x axis, it is not below x axis, it is on or above x axis, it is symmetrical about y axis. On both sides there is these two halves are like mirror images. Okay, so these are the points we can notice about this particular graph. We can remember the shape of the graph also. Okay, this shape is a parabola, this shape is a parabola, this is symmetrical about y-axis, it is on or above x-axis, it is not below x-axis. Okay, these are the points. Now we'll see, we have understood how graphs are constructed. Now we'll see a few functions. First one is identity function. Identity function. that is y is equal to x. When you construct a table x and y, then you, for 1 you get 1, for minus 2 you get minus 2, for 3.5 you get 3.5 again. So the graph which will be formed is this. It will be a straight line symmetric to both these axes. That means on both sides there is an angle of 45 degree. Okay, so this is identity function y is equal to x. Second one is square function. We just saw y is equal to x square. The shape is like this. Third one is cubic function. Third one is cubic function. Y is equal to x cube, and the graph is like this. Okay. Thereafter, fourth one is constant function. Y is equal to c, but c is difficult to understand. So let's say y is equal to 3. In place of 3, it can be anything. So this is 3. It will be parallel to x-axis. It will be parallel to x-axis. The graph of constant function. If there was minus 5, then it will be, say, here is minus 5, then sorry, it will be parallel to x-axis again. So graph of constant function is like this. Now modulus function. Fifth function is modulus function. Y is equal to mod x. It is also called absolute value function. Y is equal to mod x. Modulus function also called absolute value function. When you make a table x and y, for 1 you get 1, for 0 you get 0, for minus 2 you get 2, for 2 also you get 2, for minus 1 you get 1, for 3 you get 3, and for minus 3 you get 3. Okay, the graph will be like this. It is a steep bend, it is a sharp turn, it is not a smooth turn. It is also on or above x-axis. It is also symmetrical about y-axis, but it is not smooth. It is sharply turned at origin. It passes from origin. Okay, now the graph of reciprocal function. Reciprocal function. That is y is equal to 1 by x. Graph will be formed like this. Okay, it will tend to touch these x's, but will never be able to touch actually. Okay, at x equal to 0 this function is not defined, and at x equal to 0 this graph will not touch anything. There will be no point representing x equal to 0 on this graph. And uh, if we present this function correctly, we must say, we must attach a clause that x is not equal to 0, because if a function is given there, then it has a value associated to every input. So we have to define the set which is the allowed set of values which will give an output for sure. Okay, so after mentioning that x is not equal to 0, Now we are very clear about the reciprocal function. Earlier, when we had not mentioned it, we had a flaw that at x equal to 0 the function was not defined, but a function by definition can never be not defined. If a function is not defined at a point, it is not a function at all. Okay. So the set of values must be given for which the function is defined, and for those set of values the function must be defined everywhere. Now we have defined the set of values that except 0 this function will be defined everywhere. So we are not going to try 0, and at all other values this function is defined. So this is a function. Okay. Now we'll try drawing a few graphs. For example, x square minus 8x plus 15. By xy plot we can find this graph also, and there is another method. We have the coefficient here, this is 1, nothing is written here, so it is 1, it is positive. So, and it is a quadratic polynomial, so the graph will be like this only. Now we have to determine if this graph intersects x axis at a few points or not. So we will put this equal to 0. When y equal to 0, this will touch x axis. XY plot is one way, and we are listing on other ways. So at x equal to 3 and 5, we'll get a solution. So at x equal to 3 and x equal to 5, at both points we are getting y is equal to 0. Okay, this is our graph, this is our function, y is equal to this. So when we put x equal to 3, we get 0. When we put x equal to 5, we get 0 again. So at 3 and 5, this graph is intersecting x axis. This is 3 and this is 5, and this is the shape of the graph. So this is our graph. So it will be symmetrical here at 4. Okay, this we have automatically determined, and it solves a lot of problems. Okay, so this was another way of drawing a graph. It is not always possible. It was convenient in this particular case, so we did this. Now we'll draw conclusions from a few already given graphs. For example, this one. This is a graph. It is not a straight line, obviously. It is clear. If we talk about this graph, then for all values of x less than minus 4, for all values of x less than minus 4, again, that means beyond this point, fx will be negative because it is downwards. It is below x axis, so fx will be negative. Fx, that means y will be negative. And for all values of x greater than minus 4, fx will be positive. It is clear, it is very clear. Okay, now we see another graph here. It is 2, it is 5. So this is gx and this is fx. Okay, so we can say g2 is equal to f2. Okay, also g5 is equal to f5, and these are two intersection points of these graphs. Gx is always positive. Gx is nowhere below this, so Gx is always positive. Gx is nowhere below x axis, so it is always positive. Uh, we can also say for all values of x from 2 to 5, for all values of x from 2 to 5, Gx is less than fx. For all values of x between 2 and 5, For all values of x between 2 and 5, this gx is below fx, so it is less than fx. Okay, and for all values beyond 2 this side and beyond 5 that side, for all values of x beyond 2 this side and beyond 5 that side, gx is greater than fx. So this is how we draw conclusions from graphs. Okay, so this was the lecture for today. This is a very basic lecture. I have described very basic things. We will be discussing this chapter thoroughly, the functions chapter, in subsequent lecture. Okay, and function chapter can also be taught separately. We will continue algebra and remainder theorem, factor theorem, so on. Uh, I'll decide what I have to do in 1 or 2 days. Okay. So thanks for watching this video. Don't forget to like, share, subscribe, and if you have any doubts, send on 8294600829 WhatsApp us. Thank you so much. I repeat, like, share, and subscribe. Don't forget that. Thank you so much. Bye bye. Happy learning.